Good morning, everyone. Today we are going to be talking about exponential growth and decay. A couple of things we need to know about this. Number one, growth simply means that something is getting bigger. Decay means that something is getting smaller. And the word exponential is what we've been studying for just a little bit that indicates that we have a pattern of multiplication. Just a quick review for exponential. Here's a couple of exponential functions that I've written down here. On this first one, we can see that from step to step, we multiply by a set value. In this case, it is multiplied by 2. This function, from step to step, divides by 2 or multiplies by 1/2 for each step. Divides by 2 or multiplies by 1/2. Divides by 2 or multiplies by 1/2. Now that pattern indicates that we are working with an exponential function because we have a pattern of multiplication. This one is growth because it's getting bigger. This one is decay because it's getting smaller. Now, the types of questions we'll be moving toward look kind of like this, where we're growing or decaying by a certain percent. In this case, we just started a job with a salary set at $35,000, and the question asks, what will your salary be in 10 years if it increases by 4% every year? Now, typically, when people are doing percents, I see them doing calculations that look something like this. We figure out 4% of $35,000, and we write 4% as a decimal. That would be 0.04. Move that decimal over 2 places. Of means to multiply, and we multiply that by 35,000. 0.04 times by 35,000 happens to be $1,400. And then if we add that back into our original salary of $35,000, the next year's salary would be $36,400. And we can continue this process if we wish. However, with exponential functions, we're able to shorten that process. I want to show you how, and then we'll start to apply it. That 35,000 represents, as a percent, 100% of our salary. And if we increase by 4%, that puts our new salary at a level of 104%. Now we can turn this into a decimal and use it to multiply, and that will be our exponential function. So that would be written as a decimal, 1.04, and we multiply that by 35,000 to get us a total of $36,400 like we did before. So here is essential concept number one. We need to be able to think through this process and see if we're increasing by 4%, that would put us at 100 plus 4%, or 104%. We're going to do a couple of simple examples with that idea to get us started. Our task is to figure out if each function represents growth or decay. So does each function represent growth or decay? And by what amount is it growing or decaying? All of these here represent growth, and we're going to get to some decay in just a moment. So the growth right here is shown in this portion. That's our multiple. If you recall, we have exponential functions. Our f of x equals a times b to the x, and that is our multiple right there. So this 1 represents 100%. This 0.75 written as a percent would be 75%. If we add those together, like the problem indicates right there, that gives us 105%. and 75%. So, question, does each function represent growth or decay? In this case, we are adding 75%, so we are growing by an amount of 75%. We're going to break each of these down and figure out what they are growing by. So this one's written a little bit differently. That 1.05 written in percent form would be 105%. Now remember, our original amount represents 100%. To get to 105%, we would have to add 5%. So this one again is growth because we are adding by 5% right there. This question right here has a multiple of 2. That would be 100% plus an additional 100% to get us to the 2, which represents 200%. So this question again is growth by a total of 100%. And this last one right here, this decimal represented in percent form is 102.8%. Move that decimal over once, twice to get 102.8%. That would be 100% plus 2.8%. So this one again is growth because we are adding by 2.8%. Now let's take a look at these questions over here. These are decay, and you can see that where we have written subtraction right here. So this represents, again, the 1 is 100%. That's our original amount. This 0.6 written in percent form is 60%, and that subtraction indicates that we're going down. That puts us at a total of 40% compared to what we were at before, where we have lost 60%. So language is important here. We are decaying, we are going down. The question is by how much? We have gone down by 60%. So the language would say decay by 60%. All right, let's do the rest. This one has gone down. That written in percent form represents 75%. To get 75%, we would take our original 100% and we would subtract 25%. That leaves us with 75% left over. So this would be a decay by how much? We went down by 25%. So decay by 25%. This one is 100% minus, well, that written as a decimal is 99.5%. So we would have to subtract 0.5% to get there. So we have lost 0.5%. Again, this is decay by the amount we lost, which was 0.5%. Last one. This written as a decimal is 21.5%. That would be 100% minus 79.5. Whoa, messed up there. 78.5% to get us a total of 21.5%. So we have lost this much. Our decay this time is 78.5%. Thank you. Give the first few questions a try, and we'll see you in the next video.